In the quiet village of Dole, nestled deep within eastern France, Louis Pasteur was born on December 27, 1822, into a humble family of modest means. His father, Jean-Joseph Pasteur, a diligent and disciplined tanner, instilled a sense of meticulousness and patience that would become essential to Louis's future scientific breakthroughs. His mother, Jeannie Dionnet, gentle yet firm, encouraged her son's innate curiosity about the natural world, nurturing a sense of wonder that would follow him through life. From a young age, Louis Pasteur was captivated by the mysteries around him. In his hometown of Dole and later in the small village of Arbois, he wandered through fields and along riverbanks, fascinated by plants, insects, and the changing seasons. Observing how the simplest elements of nature, leaves, insects, and stones, seemed to hold hidden secrets, he felt an unexplainable drive to understand the complexities lying beneath their surfaces. Though his father had hoped Louis would pursue a practical profession, such as teaching or business, it was evident that young Louis was destined for something different, something more profound. In 1831, at only 9 years old, Louis began attending school at Arbois, quickly distinguishing himself among classmates with his intellectual curiosity and meticulous habits. His diligence and discipline caught the attention of his teachers, who noticed a relentless pursuit of accuracy even in minor tasks, a trait uncommon among his peers. Life was not without challenges. Louis was not a natural-born scholar. Academic subjects initially came to him with great difficulty. Latin, literature, and history, though important to his education, did not engage him nearly as much as the scientific world. His earliest years in school were marked by struggles, frustration, and frequent reprimands from teachers who did not recognize the brilliance quietly germinating beneath his struggles. Yet Louis's innate determination became his greatest ally. With unflagging persistence, he overcame these initial hurdles, slowly revealing glimpses of his remarkable intellectual capacity. By the time he reached his teenage years, Louis Pasteur's potential had begun to bloom, guided by his newfound mentor, Jean-Baptiste Barbet, a dedicated teacher who spotted the young man's exceptional potential in science. Under Barbet's careful guidance, Louis began excelling in mathematics and chemistry, laying a solid foundation that would underpin his life's work. The meticulousness he had absorbed from his father now found expression in the precision of laboratory work, the careful measurement of substances, and the diligent recording of observations. By age 16, Pasteur found himself standing at a crossroads. To remain in Arbois, comfortable but limited in opportunity, or venture into the bustling intellectual heart of France, Paris, where great scientific minds gathered, competed, and made discoveries that could alter history. After much deliberation, family encouragement, and Barbet's insistence, Louis took the decisive step. In 1839, he departed his humble childhood home in Dole, bound for Paris, carrying little more than hope, determination, and a burning passion for science. Life in Paris presented Pasteur with a profound contrast to the quiet, structured simplicity of his upbringing. He found the bustling city overwhelming at first, feeling small and insignificant among its bustling streets filled with ambitious young scholars, gifted professors, and a competitive academic environment. Yet he quickly adapted, spurred by the excitement of learning and the limitless possibilities around every corner. Admitted to the Lycée St. Louis, Louis Pasteur endured rigorous coursework and harsh critiques, often being underestimated by teachers who initially perceived him as academically unremarkable. But Pasteur's quiet persistence soon revealed itself. In small, meticulous steps, he gained respect and recognition, gradually becoming an exceptional student whose keen observations and precise reasoning distinguished him from peers. Though immersed in rigorous study, Pasteur remained closely connected to his roots. Letters home to his parents often spoke of challenges overcome, successes earned, and, most poignantly, his dreams of contributing something significant to humanity. He promised his parents he would bring honor to their modest family name, never forgetting his humble beginnings. Yet Pasteur was no stranger to doubt. His ambitions often appeared distant and uncertain. One evening, as he sat by the flickering candlelight in his modest rented room in Paris, surrounded by notes and sketches, the weight of his future bore heavily upon him. Would he succeed? Could he truly uncover nature's mysteries? Despite uncertainty, a quiet resolve remained. He knew he had to persevere, driven by an internal conviction, a belief not only in his abilities but in the importance of his quest for knowledge. As Pasteur delved deeper into scientific studies, his passion crystallized, literally and metaphorically. Soon, he became fascinated by the study of crystals, captivated by their symmetry and structure. This quiet interest would later blossom into groundbreaking research. Yet, at this moment, he simply relished the beauty of discovery, unaware that his fascination with crystallography would soon reshape the scientific community's understanding of the natural world. In these formative years, Louis Pasteur's journey had only just begun. He stood on the threshold of greatness, poised unknowingly on the brink of discoveries that would revolutionize science and medicine, forever altering humanity's relationship with disease. For now, however, he remained merely a diligent young man, studious, humble, and profoundly determined, driven by an insatiable curiosity to uncover nature's deepest secrets.
As Louis Pasteur stepped off the stagecoach into the bustling streets of Paris, his heart quickened with anticipation and uncertainty. The city before him stretched out in vivid contrast to the humble, pastoral tranquility of his childhood. Bustling streets, the cacophony of commerce, and the presence of influential intellectuals converged in the city, creating an atmosphere both exhilarating and intimidating for the young man from the modest provincial town of Dole. It was 1839, and at 17, Louis Pasteur had arrived to attend the prestigious Lycée St. Louis, hoping to transform his modest beginnings into a meaningful career. He settled into his small rented room, furnished only with the essentials, a bed, a desk, and scattered books, yet brimming with the promise of intellectual discovery. Each night, under the dim glow of candlelight, Pasteur grappled with demanding coursework, from classics and literature to mathematics and physics. But it was science, especially chemistry, that gripped him most powerfully. At first, Pasteur faced discouragement. His rural accent and humble appearance earned him little respect among his aristocratic classmates, many of whom were sons of wealthy Parisians. Teachers initially dismissed him as merely average, overlooking the quiet intensity and unwavering perseverance hidden beneath his modest exterior. Yet, Louis was patient, drawing strength from the lessons instilled by his father about perseverance, and continued to quietly and diligently prove himself through determination and hard work. Soon, Pasteur's meticulous and patient approach paid dividends. His instructors began noticing his talent in scientific inquiry, impressed by his precision and methodical approach in laboratory work. He caught the eye of influential mentors, including Jean-Baptiste Dumas, a prominent chemist whose support would prove invaluable in shaping his future. Encouraged by this recognition, Pasteur intensified his studies, growing more confident in his ability to achieve what others thought impossible. His relentless drive propelled him forward, yet financial struggles cast long shadows. Paris was an expensive city, and Pasteur's family had limited means. Struggling to afford living costs, he supplemented his meager income by tutoring younger students. Long nights of work and study became his daily routine. He often reflected on the simpler days of his youth, when curiosity alone had guided his passion, wondering if the sacrifice and hardship would one day bear fruit. But hardship bred resilience. The more obstacles Pasteur faced, the more determined he became. One evening, as he worked alone in the dimly lit laboratory, he made a crucial decision. To prove himself and build a stable career in science, he would have to do something exceptional, something that would distinguish him beyond classroom lectures and textbooks. He began exploring research topics with renewed urgency, determined to discover something profound that could secure him a respected academic post. In 1843, Pasteur entered the École Normale Supérieure, a rigorous institution that further tested his resolve. Now fully immersed in scientific inquiry, his daily life revolved around meticulous experimentation, observations, and countless hours spent analyzing minute chemical structures. Here, surrounded by scholars whose intellect and ambition matched his own, Pasteur felt challenged yet deeply inspired. Friendships formed slowly, but he earned respect from peers and professors alike through his quiet confidence, discipline, and careful attention to detail. His breakthrough soon arrived through an unlikely avenue: crystallography. A simple yet perplexing question had gripped his attention. Why did some crystals, identical in chemical composition, bend polarized light differently? The problem fascinated and puzzled Pasteur. He suspected the key lay hidden within their microscopic structure, a theory dismissed by many experts. Determined, he worked day and night, observing tiny crystals under polarized light, recording his observations meticulously, piece by painstaking piece. One evening, after hours of exhaustive analysis, he discovered something astonishing: two forms of tartaric acid crystals, chemically identical yet mirror images of each other, twisted polarized light in opposite directions. This remarkable discovery marked the first evidence of molecular asymmetry, proving that molecules could exist in forms identical in composition but structurally distinct. His findings astonished the scientific community, capturing the attention of leading chemists across Europe. Recognition and respect quickly followed. In 1847, Pasteur completed his doctorate, presenting his groundbreaking discovery to an audience of distinguished scientists. His theory of molecular asymmetry was now widely accepted, elevating his status from a humble provincial student to a respected scholar with a promising future. Yet even amidst applause, Pasteur remained modest, acutely aware that each discovery simply unlocked doors to greater mysteries waiting to be solved. Despite the acclaim, Pasteur remained humble, never forgetting his roots. He often paused, reflecting quietly on how far he had come, from a simple upbringing in Dole to making discoveries that challenged centuries of scientific belief. Still, he felt an inner urgency, an insatiable drive to explore further, knowing there was so much more hidden beneath the surface, awaiting discovery. Pasteur's formative years in Paris set the stage for an extraordinary career. His determination, born from hardship and shaped by rigorous scientific discipline, began carving his path. Each discovery reinforced his belief that meticulous observation, tireless experimentation, and bold questioning of established knowledge were essential to scientific progress. Yet, despite the acclaim now coming his way, Louis Pasteur knew that his journey was only just beginning, and that even greater challenges and discoveries lay ahead.
Louis Pasteur's groundbreaking discovery of molecular asymmetry had earned him recognition throughout the European scientific community. But as the applause faded, a new sense of purpose emerged within him. Freshly awarded his doctorate, Pasteur now stood on the threshold of a promising career in chemistry, yet the path forward remained uncertain. He pondered his next move carefully, acutely aware that scientific fame was fleeting, and only continuous discovery would secure his legacy. In 1848, Pasteur secured his first professional academic position as a professor of chemistry at the University of Strasbourg. This modest university, though less prestigious than the illustrious institutions of Paris, offered Pasteur the chance he sought to expand his scientific research beyond the walls of his cramped laboratory in Paris and into broader applications. Strasbourg was bustling, vibrant, and stimulating, the perfect place to further hone his scientific rigor. Soon after arriving, Louis Pasteur met Marie Laurent, the quiet, thoughtful daughter of the university rector. Their courtship was brief yet earnest, guided by mutual respect and shared intellectual curiosity. By May 1849, they married, marking a significant turning point in Pasteur's personal life. Marie became not only a steadfast companion but also his constant support during times of doubt and difficulty. Together, they shared dreams of a future shaped by scientific discovery and public service. At Strasbourg, Pasteur continued to delve deeply into crystallography, further refining his earlier findings on molecular asymmetry. He meticulously studied tartaric acid crystals again, demonstrating conclusively that these tiny structures held hidden properties reflective of broader natural laws. His reputation grew, though quietly. He was respected, but not yet famous. Yet Pasteur's mind constantly wandered beyond crystals, curious about the countless unanswered questions still lurking at the fringes of scientific knowledge. Then, in 1854, Pasteur accepted a prestigious position as Dean of the Faculty of Sciences at the University of Lille, shifting his focus from abstract chemistry to practical problems affecting everyday life. Lille, in northern France, was bustling with industrial activity, its prosperity tied to local agriculture and brewing industries. Winemakers and brewers often faced unexplained spoilage, threatening livelihoods and the local economy. Pasteur's arrival coincided perfectly with mounting frustration, providing a fresh chance to apply his meticulous approach to an entirely new puzzle: fermentation. Fermentation fascinated and perplexed Pasteur. What exactly caused liquids like wine or beer to spoil, becoming sour or bitter unpredictably? Conventional wisdom blamed everything from temperature fluctuations to mysterious spontaneous chemical reactions. Many considered these processes mystical, even uncontrollable, governed by mysterious forces. Pasteur, ever skeptical, doubted this vague explanation. Instead, he wondered whether microorganisms, tiny, invisible entities largely dismissed by scientists, were somehow involved. He began careful microscopic examinations, spending countless hours observing samples of wine under powerful lenses. The results astonished him. Tiny organisms, living microbes, were present whenever fermentation occurred. At first, colleagues dismissed his findings as mere coincidence, insignificant microscopic lifeforms unrelated to the actual process. Yet, Pasteur felt certain he had uncovered something critical. Determined to prove the significance of his discovery, he set up rigorous, controlled experiments to show conclusively that these microscopic organisms were not merely spectators, but active participants in fermentation. With meticulous care, Pasteur sterilized samples of grape juice, isolating them in sealed vessels, protecting them from contamination. Remarkably, fermentation ceased entirely. When microbes were reintroduced deliberately, the fermentation restarted instantly. The connection was undeniable. He had discovered that microbes themselves were responsible for fermentation and potentially spoilage. This revelation transformed Pasteur's scientific career. Suddenly, his research held enormous implications, not merely theoretical but practical, influencing industries and daily life. Wine growers, brewers, and dairy producers alike now looked to Pasteur for answers, hoping he could solve age-old problems that had plagued production and quality control. Yet, Pasteur realized his discovery hinted at something even more profound. Microorganisms played roles previously unseen, potentially affecting human health and agriculture in ways science had never considered. With newfound urgency, Pasteur began experimenting tirelessly. His laboratory in Strasbourg became a hub of activity, its shelves crowded with glass flasks, fermentation vats, and detailed notes, each one meticulously recorded. He documented how specific microbes yielded distinct results, some beneficial, others harmful. He published these findings clearly and methodically, convincing skeptics through undeniable proof, meticulous observations, and reproducible experiments. Yet the broader scientific community remained skeptical. Traditionalists still resisted the idea that invisible creatures controlled processes long attributed to simple chemical reactions. Pasteur patiently faced criticism, even ridicule. His careful method and quiet confidence, however, won supporters who slowly accepted the revolutionary idea. Microorganisms were critical actors in nature, hidden yet powerful, impacting life profoundly. By late 1854, Pasteur stood poised at a pivotal crossroads. His groundbreaking work had begun reshaping the scientific landscape, yet far greater discoveries still awaited. Ahead lay the daunting task of challenging centuries-old beliefs, confronting fierce skepticism, and uncovering deeper mysteries. Yet Pasteur was undaunted. With Marie by his side, his resolve hardened by countless trials and doubts overcome, he prepared to continue his journey, fully aware that he had opened the door to an entirely new science, microbiology, and sensing, with growing anticipation, that humanity was on the verge of a profound transformation.
By 1854, Louis Pasteur stood at the edge of widespread scientific recognition. His meticulous research had unveiled the mysterious link between microbes and fermentation, challenging centuries of accepted wisdom. Yet, despite growing interest from colleagues, skepticism lingered. Some scientists openly questioned whether these microscopic organisms truly influenced everyday processes or if Pasteur had exaggerated their role. Facing skepticism, Pasteur refused to back down, determined instead to expand his studies into even more impactful territory. In 1854, Pasteur was appointed Dean of the Faculty of Sciences at Lille, a bustling industrial city steeped in commerce, industry, and particularly brewing and distilling. Lille's vibrant industries provided an ideal environment to test his fermentation theories practically. Local brewers struggled with unpredictable spoilage, puzzled by batches of beer turning sour seemingly without explanation. The economic stakes were high. Spoilage caused massive losses each year. Pasteur sensed an opportunity. Perhaps his microbes held the answer not just to scientific curiosity, but to practical economic problems. Soon, Pasteur immersed himself entirely in this real-world challenge. Each day found him deep in experimentation, carefully extracting samples from brewing vats, meticulously documenting every stage of the fermentation process. He observed that successful batches always contained particular strains of microbes, producing alcohol and flavor consistently, whereas spoiled batches harbored distinctly different organisms. The pattern was undeniable. He had discovered that fermentation was not random but governed by specific microbes, some beneficial, others destructive. If he could control these microbes, he realized, the spoilage problem could finally be solved. Pasteur's dedication soon paid off. He proved conclusively that each fermentation type, whether making beer, wine, or vinegar, depended on specific microorganisms. More importantly, he uncovered that unwanted microbes caused spoilage, transforming good products into bitter, sour liquids. This discovery was revolutionary. It revealed a path forward: identify and control microbes, and one could prevent costly economic losses. Industry leaders took notice. Suddenly, Pasteur's work gained not just scientific but commercial significance. Despite these successes, Pasteur faced new resistance. Established industries were hesitant to accept advice from a scientist who spoke of invisible organisms influencing their profits. Skeptical factory owners and brewers questioned why traditional methods needed changing at all. Pasteur, patient yet firm, organized public demonstrations. He invited skeptics to witness firsthand how sterilizing containers and controlling exposure to air prevented spoilage. The practical results spoke volumes. One by one, critics became supporters, convinced not by theory alone but by Pasteur's clear, undeniable proof. Word of Pasteur's successes spread rapidly beyond Lille, attracting attention from across France and even abroad. His findings promised improvements not only in brewing but also in preserving food products, a revelation particularly crucial for the dairy industry. Milk spoilage posed severe health risks, especially to children, leading frequently to illness or even death. Pasteur immediately recognized the potential human benefit of his microbial theories. Perhaps microbes, controlled properly, could make milk, a staple of human diet, safe for millions. In late 1856, Pasteur shifted his focus toward milk. Using methods he perfected with beer and wine, he began experimenting intensively. Initially encountering setbacks, he learned quickly how subtle temperature changes dramatically impacted microbes' activity. He discovered a precise balance. Moderate heat, neither too high nor too low, could eliminate harmful microbes without ruining taste or nutritional value. The exact point at which milk became safe yet remained nourishing had eluded scientists for generations. But Pasteur, working methodically through countless trials, finally found it. In 1857, Pasteur unveiled the results of his exhaustive studies to the scientific community. He proposed gently heating milk to roughly 60 degrees Celsius for a short period, a precise, controlled procedure that killed harmful microbes yet preserved taste and nutrients. This groundbreaking process, soon named pasteurization in his honor, would become a milestone in public health, ensuring safe consumption for generations to come. Although initially met with cautious curiosity, it quickly gained momentum. Families, dairy farmers, and eventually entire cities adopted Pasteur's recommendations, experiencing dramatic reductions in illness and deaths linked to spoiled milk. The immediate acclaim brought Pasteur widespread attention, yet he remained humble. For him, science was never about personal glory, but always about alleviating human suffering. Despite sudden fame, he quietly continued his experiments, knowing his discovery had opened doors to an entirely new field of inquiry: microbiology. He understood clearly that microbes were not mere scientific curiosities. They held keys to human health, agriculture, and industry. Yet even as Pasteur stood on the brink of new challenges, his accomplishments already resonated globally. The young man who once struggled academically had become one of France's most celebrated scientists, his theories now discussed in universities and factories across Europe. Despite widespread acceptance, Pasteur privately knew his journey was far from complete. He felt compelled, almost obligated, to delve deeper, to understand more profoundly the invisible world that held humanity's fate within its delicate grasp. Thus, as the year drew to a close, Pasteur stood poised on the threshold of greatness. He had proven the immense practical value of microbiology. Yet even he could scarcely imagine how profoundly his work would reshape the scientific and medical worlds in the coming years. Driven by a relentless curiosity, Pasteur stood ready once again to challenge conventional wisdom, knowing that the invisible microbes he had revealed would soon lead him toward greater discoveries and an even brighter legacy.
By 1857, Louis Pasteur's revolutionary discoveries in fermentation had earned him considerable acclaim across Europe. His work had shown conclusively that microscopic organisms were responsible for processes that had long mystified humanity, particularly fermentation and spoilage. Yet, despite these successes, Pasteur knew that another, perhaps greater challenge awaited him: a scientific battle that could redefine the very understanding of life itself. At the heart of this debate lay the centuries-old belief known as spontaneous generation, the idea that life could arise suddenly and naturally from non-living matter. For generations, scientists and ordinary people alike believed flies emerged spontaneously from decaying meat, mice from dirty rags, and molds from spoiled broth. Despite mounting evidence against it, spontaneous generation stubbornly persisted as a widely accepted theory, influencing not just scientific thought but public attitudes toward hygiene, medicine, and even disease prevention. Pasteur found the notion absurd, directly contradicting everything he had observed. How could life arise without cause, spontaneously appearing from nothing? He felt compelled to prove conclusively that spontaneous generation was impossible. Yet disproving a belief held deeply across Europe would require extraordinary proof, experiments meticulously designed, flawlessly executed, and undeniably clear. In 1859, Pasteur embarked on what would become his legendary experiments. Drawing from his experience in fermentation, he crafted ingenious glass vessels now famously known as swan neck flasks. These oddly shaped vessels had thin, curved necks allowing air in, yet preventing microscopic particles and organisms from entering the sterile nutrient solutions within. If spontaneous generation truly existed, Pasteur reasoned, life would still appear, no matter how well protected the environment. If not, his carefully controlled conditions would remain lifeless indefinitely. Weeks passed in tense anticipation. The scientific community watched closely. Critics openly doubted Pasteur's approach, labeling his experiment overly elaborate, unnecessary, even foolish. But Pasteur patiently waited. Days turned into months, and each sterile flask remained clear, perfectly free of life. Not a single microbe appeared spontaneously. Yet skeptics remained unconvinced, challenging Pasteur's results as incomplete or flawed, unwilling to abandon beliefs they had embraced for generations. To silence his critics decisively, Pasteur introduced a final, dramatic step. He tilted a flask slightly, allowing the sterilized liquid within to contact the microbes that had settled in the curved neck. Almost immediately, microbial growth erupted. Life appeared, unmistakably demonstrating that microbes could only originate from previously existing life, never spontaneously from non-living matter. The implications were profound. With simple elegance and clarity, Pasteur shattered centuries of scientific misconception. Life, he proved, came only from existing life, not spontaneously from inanimate materials. This monumental experiment, now famously known as the swan neck flask demonstration, reshaped the scientific landscape, laying the foundations of modern microbiology. Pasteur's success reverberated throughout Europe, creating excitement and controversy alike. He had succeeded not only in disproving spontaneous generation, but in revealing a hidden world of microbes, organisms invisible to the naked eye yet profoundly influential in all aspects of nature. Yet even as Pasteur celebrated privately, he knew that his victory was more than scientific. It carried tremendous implications for medicine and public health. If microbes did not spontaneously appear, how did they spread? How did diseases emerge? And more critically, how could they be controlled? He realized that microbes held the key not only to understanding life but preventing disease and suffering. Pasteur's thoughts raced ahead, sensing the enormous implications of his discovery. His scientific ambitions now aligned with a broader purpose, protecting humanity itself. In 1861, Pasteur traveled extensively, sharing his revolutionary findings with scientists across France, England, and Germany. Despite overwhelming evidence, opposition persisted, driven by pride, stubbornness, or fear of overturning long-standing beliefs. Pasteur patiently listened to arguments, calmly countering skepticism with carefully documented results. Each public demonstration provided undeniable proof, slowly dismantling skepticism and replacing it with astonishment, admiration, and, eventually, acceptance. Throughout these intense years, Pasteur relied deeply upon his wife Marie's steady support. She watched quietly from the sidelines, always believing in him even as critics dismissed his findings as radical or absurd. Marie's unwavering faith fueled his determination, strengthening his resolve in moments of doubt. And doubt often crept in. Had he done enough? Had he overlooked something critical? Still, each success reassured him, pushing him forward through sleepless nights spent meticulously reviewing his results, planning ever more conclusive experiments. Finally, by late 1862, The scientific community began widely accepting Pasteur's conclusions, albeit cautiously at first. Skepticism faded, replaced gradually by admiration. Academies awarded him medals. Universities invited him to lecture. His discovery was not merely scientific. It resonated culturally, reshaping society's understanding of life itself. Pasteur's reputation soared. Yet, despite growing acclaim, he remained humble, never forgetting the importance of patience, precision, and perseverance. Qualities he first learned from his father in a humble tannery decades earlier. Yet Pasteur knew this victory marked only a beginning. By revealing microbes as active, living entities, he had unlocked doors leading to even more profound questions. Could microbes also cause diseases? Could controlling these tiny organisms help eliminate human suffering on an unprecedented scale? His mind already raced forward, envisioning future battles, greater discoveries, and the transformative power of his emerging germ theory. By late 1862, Pasteur stood poised at a new frontier, one far more ambitious than he ever imagined. His victory against spontaneous generation had prepared the path, clearing misconceptions from the field. Ahead lay battles yet unimagined, but Pasteur faced the future without fear. His relentless curiosity, rigorously disciplined mind, and profound humility made him uniquely suited for the monumental challenges awaiting him. One great discovery had ended. Yet another, perhaps even greater, was about to begin.
Louis Pasteur had spent years dismantling the deeply ingrained belief in spontaneous generation. Yet even as he emerged victorious, he knew his work was far from finished. His research had revealed a hidden world of microscopic life, a world teeming with unseen forces capable of shaping human existence. If these tiny organisms could influence fermentation, could they also be responsible for the spoilage of food? The sickness of livestock? The unexplained deaths of children? The questions crowded his mind, demanding answers. By 1862, Pasteur turned his focus to an urgent problem affecting France's agricultural economy, the mysterious and costly spoilage of wine. Vineyards across the country had struggled for years, watching helplessly as entire batches of wine soured before reaching the market. The economic loss was staggering, and traditional winemakers had no explanation. Some blamed the barrels, others the climate, but none suspected what Pasteur had already proven elsewhere. Microbes were at work, unseen yet powerful. Determined to find a solution, Pasteur set up experiments in a winery, carefully collecting samples of good and spoiled wine. Under the microscope, the difference was undeniable. Healthy wine contained uniform, oval-shaped yeast cells, working as nature intended. Spoiled wine, however, teemed with strange, misshapen microbes, intruders that twisted the flavors, turning rich wines into vinegar. Pasteur now understood what was happening. These rogue microbes were contaminating the wine, overtaking the natural fermentation process and ruining entire barrels. If he could find a way to destroy them without damaging the wine itself, he could save an entire industry. Weeks turned into months as Pasteur tested solution after solution. Boiling the wine killed the unwanted microbes, but also destroyed the delicate flavors. Cooling it did nothing. Filtering it removed impurities but failed to halt the spoilage. The challenge was precise: how to eliminate harmful bacteria without altering the product's essential nature. He needed a method that walked the fine line between preservation and destruction. Then, after tireless experimentation, Pasteur made a breakthrough. By heating the wine to a specific temperature, neither boiling nor lukewarm, he could kill the spoilage-causing microbes while preserving the wine's flavor. It was a delicate balance, a solution so simple yet so precise that it stunned those who witnessed it. He had done it. He had devised a process to protect one of France's most valuable products from microbial ruin. But Pasteur did not stop there. If wine could be saved, why not beer? Why not milk? These questions consumed him, and soon his experiments expanded. He began testing his heating process on milk, suspecting that the same invisible enemies that ruined wine also lurked in this essential food. Unlike spoiled wine, which was an economic loss, contaminated milk posed a far deadlier threat, one that struck the most vulnerable members of society. For centuries, milk had been a silent killer. Infants and young children, the primary consumers of milk, frequently suffered from severe illness, fevers, and convulsions with no known cause. Entire families mourned the sudden loss of seemingly healthy children, their deaths unexplained, their suffering a mystery. Physicians could do little but watch helplessly, unaware that milk-borne diseases such as tuberculosis, typhoid, and brucellosis were quietly claiming thousands of lives. Pasteur suspected that, just like in wine, harmful microbes in milk were to blame. His suspicions deepened as he examined milk samples under the microscope, finding them crawling with bacteria, living organisms invisible to the naked eye, but capable of deadly consequences. If heating could protect wine, could it do the same for milk? He conducted rigorous trials, heating milk just enough to kill dangerous bacteria but not enough to alter its composition. The results were astonishing. Not only did the process eliminate harmful microbes, but it also extended the milk's shelf life, making it safer for transportation and consumption. With urgency, Pasteur published his findings, detailing the exact temperatures and exposure times necessary to purify milk while preserving its nutrients. The process, soon named pasteurization in his honor, was revolutionary. It offered protection against unseen killers, transforming milk from a source of hidden danger into a safe and stable food. Yet, despite the undeniable evidence, skepticism persisted. Dairy farmers resisted change, unwilling to adopt a process they saw as unnecessary interference. Consumers, unaware of the microbes lurking in their milk, dismissed the warnings as exaggeration. Pasteur faced an uphill battle. His greatest challenge was not proving his science, but convincing the world to accept it. He traveled across France, demonstrating his process to farmers, doctors, and public officials. Slowly, attitudes began to shift. Mothers who had lost children to mysterious fevers embraced his discovery, desperate to protect their remaining young. Hospitals took notice. Governments debated regulations. The tide was turning. Then, in 1865, tragedy struck Pasteur's own household. His beloved daughter Camille, just 9 years old, fell ill with typhoid fever. He watched helplessly as she grew weaker, her small body consumed by a sickness he had spent years trying to understand. Despite the best medical efforts, Camille succumbed, leaving Pasteur devastated. The loss shattered him, but it also deepened his resolve. No child should suffer as his had. No parent should endure such grief. The answer was there, within reach. Scientific progress could prevent these senseless deaths. But only if people were willing to listen. With renewed urgency, Pasteur intensified his public efforts, determined to see pasteurization widely adopted. The impact was undeniable. Hospitals that implemented the process saw infant mortality rates drop. Dairy farms that sterilized their milk saw fewer cases of disease. Slowly but steadily, society awakened to the invisible threat lurking in their daily lives, and to the power of science to fight it. As the decade neared its close, Pasteur stood at the center of a medical revolution. His work had already changed the way humanity viewed food, disease, and hygiene. Yet he knew that pasteurization was only the beginning. If microbes could be controlled in food, could they also be controlled in the human body? Could the same principles that protected milk also prevent the spread of deadly diseases? These thoughts consumed him, pulling him toward new experiments, new questions, and new battles yet to be fought.
Louis Pasteur had already revolutionized the understanding of microbes, proving their role in fermentation and food spoilage. Yet even as his work on pasteurization gained recognition, another crisis loomed. This time, the problem did not affect wine or milk. It threatened an entire industry, one that had sustained France's economy for generations. The silk industry, a cornerstone of French commerce, was collapsing. Silkworms, once the lifeblood of a thriving trade, were dying in vast numbers, and no one knew why. For years, silk farmers had watched helplessly as their once thriving silkworm colonies withered. Larvae that had hatched healthy soon became weak, their bodies covered in strange, powdery spots before perishing. Entire silk farms lay in ruin, their losses mounting with each failed season. The economic devastation spread across the country, with silk production plummeting and thousands of workers facing ruin. France's once booming silk trade stood on the edge of collapse, and desperate farmers turned to the government for answers. In 1865, officials sought out Pasteur, urging him to investigate the silkworm crisis. At first, he hesitated. He was not an entomologist, nor had he studied insects in any serious capacity. His expertise lay in chemistry, microbiology, and fermentation. What could he possibly contribute to an agricultural disaster? Yet, the more he learned, the clearer it became this was not simply an agricultural problem. It was a scientific mystery, and if he had learned anything from his studies on microbes, it was that unseen enemies could be far deadlier than visible ones. Reluctantly, Pasteur left his laboratory behind, traveling to the heart of the silk-producing regions in southern France. He immersed himself in the unfamiliar world of silk farming, spending weeks observing the silkworms, questioning farmers, and documenting every stage of their growth. It did not take long for him to notice something unusual. In the dead and dying larvae, he observed tiny granules, strange, powdery particles that had no business being inside living creatures. He had seen something similar before, under a microscope in the spoiled milk and wine he had studied years earlier. Was it possible that microbes, so small, so overlooked, were also responsible for this deadly silkworm disease? The idea was radical. Farmers had long believed the disease came from poor air, bad feed, or even mysterious environmental curses. Few considered that the disease could be caused by something they could not see. Yet, Pasteur had learned to trust what his microscope revealed, not what tradition dictated. He began an exhaustive investigation, determined to uncover the truth. Every morning, he rose before dawn, meticulously recording the conditions of infected silkworms, examining their bodies, and comparing healthy larvae to diseased ones. Day after day, he searched for patterns, testing theories, discarding false leads, and returning to his microscope for answers. The work was painstaking, slow, frustrating. At times, he doubted himself. Had he accepted a task beyond his capabilities? Would this be the problem he could not solve? He wrestled with exhaustion, uncertainty, and the creeping fear of failure, but he refused to give up. Then, after months of observation and analysis, the breakthrough came. The tiny granules he had noticed earlier were not merely byproducts of the disease. They were the disease itself. Microscopic parasites, invisible to the naked eye, were invading the silkworms' bodies, infecting them before they even hatched from their eggs. This meant that sick silkworms were not just victims. They were carriers. They spread the infection to their offspring, dooming entire generations before they even began. With this knowledge, Pasteur devised a radical solution. If infected silkworm eggs could be identified and destroyed before they hatched, the disease could be eradicated. He developed a method to examine eggs under a microscope, separating the healthy from the diseased. It was a meticulous process, but it worked. Farmers who followed Pasteur's method saw immediate improvements. Their silkworms survived, their crops flourished, and silk production began to recover. At first, skeptics resisted. Could the fate of an entire industry really be decided by something as simple as a microscope? Yet, as more farmers adopted Pasteur's methods, the evidence became undeniable. Year by year, silk production stabilized. The crisis that had threatened to destroy one of France's most valuable industries was finally under control. Pasteur's triumph extended far beyond the silk trade. His success proved a principle that would shape medicine, agriculture, and microbiology for decades to come. Diseases were not caused by mysterious forces or bad luck. They had causes, identifiable, observable, and most importantly, preventable. The implications were staggering. If microscopic organisms could infect silkworms, could they also be responsible for human diseases? Could they be stopped before they spread? Pasteur's mind raced with new questions, new possibilities, new frontiers waiting to be explored. By 1870, Pasteur had become more than a chemist, more than a microbiologist. He was a savior to industries, a man whose discoveries not only advanced science but protected entire livelihoods. Yet, he felt no sense of completion. If anything, he felt an urgency greater than ever before. He had seen firsthand the devastation an invisible enemy could cause. He had battled microbes in food, in insects. But what about in the human body? The world was on the brink of discoveries that would change medicine forever. The germ theory of disease, vaccines, immunity. It was all there, just beyond reach. Pasteur knew that if he did not pursue these questions, if he did not uncover the truth, countless more lives would be lost. Children, mothers, soldiers, entire communities. He could not allow that to happen. Even as the silkworm crisis faded into history, Pasteur's journey was far from over. He had conquered one invisible enemy, but others waited, lurking in hospitals, in drinking water, in the blood of the sick. He had glimpsed the future of medicine, and he knew what had to be done. There was no turning back now. The fight against disease had only just begun.
Louis Pasteur had spent years battling unseen enemies, microscopic killers responsible for food spoilage, agricultural devastation, and economic ruin. But as the decade turned, a far greater conflict erupted, one that had nothing to do with bacteria. France itself was at war. In 1870, the Franco-Prussian War ignited, plunging the nation into chaos. As Prussian forces advanced across the countryside, destruction spread far beyond the battlefield. Factories shut down, food supplies dwindled, and disease thrived in the crowded, unsanitary conditions of besieged cities. Pasteur, though not a soldier, felt the war's impact deeply. His laboratory in Paris, once a sanctuary of discovery, now stood empty, abandoned as the city fell under siege. Scientific work was no longer a priority. Survival was. Pasteur's mind, however, never ceased searching for solutions. Disease, he realized, was as much an enemy as any invading army. Soldiers weakened by infection fell before they could fight, and civilians trapped in unsanitary conditions suffered as much as those struck by bullets. Cholera, typhoid, and dysentery ravaged the population, spreading unchecked in the filth of war. And yet, even in these desperate times, the medical world still clung to outdated beliefs about disease. Pasteur had long suspected that microbes played a role in human illness, but now, surrounded by suffering, the urgency of proving it grew unbearable. If he could show that bacteria caused disease, just as they spoiled wine and sickened silkworms, medicine itself could be transformed. But war made research nearly impossible. His funding dried up, and communication with fellow scientists was severed. He could do little but wait, watch, and plan for the battles he would fight when peace returned. In 1871, when the war finally ended, France lay in ruins. The loss to Prussia had shattered the nation's pride, and the people looked for ways to rebuild, to reclaim their former strength. Pasteur, though devastated by the suffering he had witnessed, saw an opportunity. If France wanted to regain its standing in the world, it needed not only military power but scientific advancement. He presented his ideas to government officials, arguing that research, real, practical research, could prevent future suffering. Disease had crippled France's army as much as enemy fire. But what if it could be controlled? The response was slow, but his reputation as a national hero, having saved the silk industry, gave weight to his words. Funding returned, laboratories reopened, and Pasteur wasted no time. He was now determined to prove, beyond any doubt, that microbes caused disease. The medical community, however, remained deeply divided. Many still clung to the idea that sickness arose from imbalances in the body or from miasmas, poisonous air floating through cities. Pasteur's theories challenged centuries of medical teaching, and not everyone welcomed such disruption. Despite resistance, Pasteur pressed forward. He turned to a disease that had long plagued farmers, anthrax. This deadly infection, striking cattle and sheep without warning, had devastated livestock populations for generations. Farmers could do little but watch as entire herds succumbed to the strange, invisible killer. Some blamed bad weather. Others believed in a mysterious curse on the land. But Pasteur suspected something else, something microbial. In 1873, he began a meticulous study of anthrax, gathering samples from infected animals and examining them under his microscope. What he found was astonishing. Every infected animal contained rod-shaped bacteria, identical in every case. This was no coincidence. These bacteria, Pasteur believed, were not bystanders. They were the cause of the disease itself. If he could prove this, the implications would be staggering, not just for livestock, but for all infectious diseases. But how could he be sure? His enemies were invisible, undetectable without a microscope, and his critics demanded more than mere observations. Pasteur needed an experiment so conclusive that even his fiercest opponents would be forced to accept the truth, and so he devised a plan. He took healthy animals, sheep, cattle, and guinea pigs, and exposed them to the bacteria found in diseased animals. If his theory was correct, they too would become sick. If he was wrong, they would remain healthy, proving that the bacteria were irrelevant. The results were undeniable. Every single exposed animal developed anthrax, while those kept separate remained unharmed. Even then, some skeptics refused to yield. They argued that the bacteria might appear after the disease, rather than causing it. Frustrated but undeterred, Pasteur pushed his experiments further. He isolated the bacteria, grew them in pure cultures, and then introduced them to new animals. Once again, the disease followed. His conclusion was inescapable: germs caused disease. The germ theory of disease had been born. It was a revelation that would change medicine forever. No longer could doctors ignore the microscopic world. No longer could disease be blamed on bad air, curses, or imbalances of bodily fluids. There was now undeniable proof. Illness had a cause, and that cause could be studied, understood, and perhaps even prevented. By 1876, Pasteur's discoveries had begun to spread, reaching beyond France to scientists and physicians across Europe. Some embraced the findings immediately, recognizing the potential for revolutionizing medical treatment. Others resisted, clinging to tradition, unwilling to accept that tiny, invisible creatures could shape human health so profoundly. But the tide was turning, and Pasteur knew that his work was far from complete. If bacteria could cause disease, then the next question was clear: could they also be stopped? Was it possible to prevent sickness rather than simply react to it? The answer, he suspected, lay in vaccines, a concept that had been little explored since Edward Jenner's early work with smallpox decades earlier. If microbes caused disease, then perhaps weakened or dead microbes could protect against disease as well. The idea was bold, untested, and dangerous. But for Pasteur, it was irresistible. He had seen enough suffering: soldiers dying in war, farmers losing their livestock, children perishing from illnesses no one understood. He could not stand idly by when the answers might be within reach. And so, even as his anthrax experiments concluded, Pasteur's mind leaped forward to the next battle. He had fought microbes in the fields, in food, in industries. But now, for the first time, he was preparing to take the fight directly into the realm of medicine itself. The war against disease had begun, and there was no turning back now.
Louis Pasteur had spent years proving that microbes were responsible for fermentation, food spoilage, and disease. Yet despite his groundbreaking discoveries, many in the medical and scientific communities still resisted his conclusions. The germ theory of disease, though gaining traction, remained a controversial idea. Doctors and veterinarians clung to outdated notions, dismissing the idea that tiny, invisible organisms could be responsible for deadly infections. But Pasteur had grown accustomed to skepticism, and he knew exactly how to silence it through undeniable proof. By 1877, anthrax had become his next great battle. The disease was a relentless killer, devastating livestock across Europe. Farmers, desperate and powerless, watched helplessly as entire herds succumbed to the mysterious illness. The symptoms were swift and brutal: fever, swelling, difficulty breathing, followed inevitably by death. Thousands of animals perished each year, with no cure, no prevention, and no understanding of why the disease spread so quickly. But Pasteur suspected the answer lay where it always had, in the invisible world of microbes. His early studies of anthrax had already confirmed the presence of rod-shaped bacteria in the blood of infected animals. He had seen them multiply, attacking healthy tissue, spreading destruction from within. But where did these bacteria come from? How did they persist, even when no infected animals were present? The answer came in a discovery that stunned even Pasteur himself: anthrax spores. Unlike ordinary bacteria, which needed a host to survive, anthrax bacteria had a terrifying ability. When exposed to harsh conditions, they transformed into dormant spores, microscopic and nearly indestructible. These spores could lie hidden in the soil for years, waiting for the right conditions to awaken. When livestock grazed on contaminated land, they unknowingly consumed the spores, and the disease began again. This explained why outbreaks seemed to appear from nowhere, striking the same farms again and again. The implications were staggering. If anthrax spores could remain in the environment indefinitely, then simply removing infected animals would never be enough. The disease could not be cured, it had to be prevented. And that meant only one thing: Pasteur needed to develop a vaccine. The idea was not new. Edward Jenner had successfully used cowpox to protect against smallpox decades earlier. But anthrax was different. No one had ever created a vaccine from a bacterium before. The risks were enormous. If Pasteur failed, if he accidentally strengthened the bacteria rather than weakened them, he could cause an even deadlier outbreak. Yet, despite the dangers, he pressed forward, certain that science could unlock the answer. The key, he believed, lay in attenuation, weakening the bacteria so that they no longer caused disease but still triggered the body's immune defenses. But how could he weaken a killer as powerful as anthrax? The solution came, as so many of Pasteur's discoveries had, through relentless experimentation. He exposed anthrax bacteria to heat, testing different temperatures and durations, carefully monitoring their survival. He introduced them to oxygen, depriving them of their natural environments, watching as they struggled to grow. Each experiment brought new failures, new frustrations. Yet Pasteur refused to be discouraged. He knew the answer was there, waiting to be uncovered. Then, at last, the breakthrough came. By exposing the anthrax bacteria to controlled heat and oxygen for a specific period, Pasteur found that they lost their virulence. They could still survive, but they could no longer cause severe illness. It was a triumph. These weakened bacteria could now serve as a vaccine, training the immune system to recognize and fight anthrax before a real infection took hold. But theory was not enough. It had to be tested. And for that, Pasteur needed a public experiment, one that would leave no room for doubt. In 1881, he found the perfect opportunity. A prominent veterinarian, skeptical of Pasteur's theories, challenged him to prove his vaccine in front of an audience of farmers, doctors, and journalists. The challenge was set at a farm in Paoli-le-Fort. Pasteur accepted without hesitation. He saw this not as a test, but as a final battle, one that would either cement his legacy or destroy it. 50 sheep were selected for the trial. Pasteur divided them into 3 groups. The first 25 were vaccinated with his weakened anthrax strain. The second 25 received nothing. 2 weeks later, all 50 sheep were deliberately exposed to live, deadly anthrax. The world watched, waiting, doubting. Days passed. Then the results became undeniable. Every vaccinated sheep remained perfectly healthy. Every unvaccinated sheep died. The stunned crowd, many of whom had arrived as skeptics, erupted in astonishment. Pasteur had done it. He had conquered anthrax not with medicine but with prevention. The newspapers carried the story across France. Farmers rejoiced. The scientific community could no longer deny the truth: microbes cause disease, and they could be defeated. The impact of the experiment was immediate. Within months, farmers across France demanded Pasteur's vaccine, eager to protect their livestock from the once unavoidable scourge. Governments took notice. Other scientists, even those who had mocked him, now sought his advice. The world had changed, and Pasteur stood at the center of it. Yet, even as he celebrated, his mind had already moved forward. If a vaccine could prevent anthrax, what about other diseases? What about rabies, cholera, tuberculosis? The possibilities were endless. His victory at Paoli-le-Fort had proven more than just the power of vaccines. It had proven that disease itself could be fought before it even began. No longer would humans be at the mercy of invisible killers. Science had given them the power to fight back. But there was still so much more to be done. He had saved livestock, but now he turned to a far greater challenge: saving human lives. The war against disease had entered its most crucial phase, and Pasteur was ready for battle.
Louis Pasteur had already conquered anthrax, but he knew his most important battle was still ahead. He had proven to the world that vaccines worked, that microbes caused disease, that prevention could triumph over infection. Yet even as farmers lined up for his anthrax vaccine, another, far deadlier killer lurked in the shadows: rabies. Unlike anthrax, which threatened livestock, rabies was a human disease, one that struck suddenly, without warning, leaving its victims in a state of unimaginable terror and ultimately inescapable death. Rabies was unlike any disease Pasteur had encountered before. It did not merely weaken the body, it attacked the brain. Once symptoms appeared, there was no cure, no hope. Madness, convulsions, a slow descent into agony. No one had ever survived rabies, not once. The mere mention of the disease sent chills through communities. It was feared like the plague, spreading silently through the bites of rabid dogs, wolves, and other infected animals. Doctors could do nothing. They could stitch wounds, apply bandages, cauterize bites with red-hot irons, but it was useless. Once rabies took hold, death followed swiftly, cruelly, without mercy. Pasteur refused to accept this fate. If he had stopped anthrax, could he not stop rabies? If microbes caused the disease, could they also be weakened, controlled, defeated? The idea of a rabies vaccine was unthinkable. Unlike anthrax, whose bacteria could be studied under a microscope, Rabies offered no such luxury. The germ responsible for rabies was invisible, too small to be seen, too elusive to be identified. Pasteur knew he was hunting an enemy he could not even see, but that only made him more determined. He began studying infected animals, dogs, rabbits, rats, all bitten by rabid creatures. He observed them obsessively, searching for patterns, clues, anything that might reveal the secret of rabies. Slowly, he realized that the disease spread through the nervous system, creeping toward the brain before taking full control. The answer, he suspected, lay not in the blood, but in the brain itself. He and his team carefully extracted spinal cord samples from rabid animals, studying them with relentless focus. How could the deadly force within them be weakened? How could rabies be tamed? Experiment after experiment failed. Some attempts killed animals instantly, others had no effect at all. But Pasteur refused to be discouraged. The stakes were too high. Rabies was a death sentence, unless he could stop it. Then, after months of testing, an astonishing breakthrough emerged. By drying infected spinal cords in sterile air, Pasteur discovered that the rabies virus weakened over time. The fresher the sample, the deadlier the virus. But as it dried, as the days passed, the virus lost its power. It could still trigger an immune response, but it could no longer kill. Pasteur had done it. He had found a way to create a weakened form of rabies, just as he had with anthrax. But he knew that proving it in animals was not enough. He needed to prove it in humans. And that meant the greatest risk of all. By 1885, he had tested his weakened rabies virus in dozens of dogs, successfully immunizing them against the disease. The results were spectacular. The vaccinated dogs, when later exposed to full-strength rabies, survived. They were immune. They lived. The vaccine worked. But testing on humans was another matter entirely. No ethical board existed. No laws guided human experimentation. And rabies was no ordinary disease. If the vaccine failed, it could make the infection worse, hastening death instead of preventing it. Pasteur hesitated. Could he risk a human life? Could he live with the consequences if he was wrong? Then, in July 1885, the decision was made for him. A mother arrived at his laboratory, desperate, pleading, out of options. Her son, 9-year-old Joseph Meister, had been savagely attacked by a rabid dog. The boy had been bitten over a dozen times. Deep wounds, bleeding, raw. The infection was almost certain. Joseph was going to die. Pasteur faced the most agonizing decision of his career. If he did nothing, the boy would suffer an unspeakable death. But if he administered the vaccine and failed, he would be responsible for ending an innocent life. The weight of the decision crushed him. 4 hours, Pasteur debated. His colleagues were divided. Some urged him to act. What did he have to lose? Others warned him, if he failed, his entire career, his reputation, his very life's work would be destroyed. He was not a physician. If he intervened, he risked being labeled a murderer. But then Pasteur looked at Joseph Meister, saw the boy's terrified eyes, saw the mother, weeping, begging for hope. And he made his decision. That night, Pasteur administered the first dose of the vaccine, praying he had made the right choice. He had never been more afraid in his life. The treatment continued over the next 10 days. One injection, then another, and another. Each morning, Pasteur awoke with dread, expecting the first symptoms to appear. If Joseph began to convulse, if fever set in, if his breathing became erratic, it would mean failure. And failure meant death. But the days passed. And Joseph did not fall ill. 1 week. Then 2. Then a month. No symptoms. No fever. No madness. No death. Joseph Meister had survived. Pasteur had done the impossible. The news spread like wildfire. A cure for rabies. The disease that had haunted humanity for centuries, the disease that had no survivors, now had a weapon against it. Crowds gathered outside Pasteur's lab. Parents carried in their bitten children. Farmers arrived, holding back tears, bringing their infected sons, daughters, loved ones. The laboratory was overwhelmed. In the months that followed, Pasteur treated dozens of rabies victims. Then hundreds. The vaccine worked, again and again and again. Rabies was no longer a death sentence. Pasteur had saved not just one life, but countless lives. And the world would never be the same. Even as the accolades poured in, even as nations celebrated him, Pasteur remained humble. It was never about fame. It was never about recognition. It was about stopping suffering, about saving lives. But he knew there were more battles to fight, more diseases to conquer, more discoveries to be made. And Pasteur was not finished yet.
Louis Pasteur had spent decades battling the invisible enemies of humanity. But now, his greatest battle was with time itself. His body, once filled with the energy of discovery, had grown frail. The stroke he had suffered in 1868 had left lingering weakness, and each passing year made even the simplest movements a struggle. Walking was difficult. Writing took immense effort. Speaking for long periods exhausted him. Yet his mind remained as sharp as ever, still racing with ideas, still searching for answers, still unwilling to stop. The Pasteur Institute, his greatest creation, had begun to flourish. Scientists from across the world had come to Paris, eager to continue the work he had started. They studied disease with a new understanding, using the germ theory as their guiding principle, building upon the foundation that Pasteur had laid with such tireless determination. Every day, breakthroughs emerged, advances in microbiology, new vaccines, improved sanitation methods. The world was changing because of what he had discovered, but Pasteur still felt there was more to be done. He had dedicated his life to science, but science had never been just about knowledge. It was about saving lives. He had seen too much suffering, too many deaths that could have been prevented. Even as the Institute expanded, even as his work was honored across nations, Pasteur remained restless. He could not be content simply watching from the sidelines. He needed to work, but his body would not allow it. By 1892, Pasteur was no longer able to conduct experiments himself. He relied on his students, his trusted researchers, to carry out his ideas. He would dictate instructions from his chair, carefully reviewing every detail of their work, guiding them as he had always done. The young scientists at the Institute revered him. They knew they were working under a man who had not only changed science, but changed the fate of humanity itself. Even as the world celebrated his achievements, Pasteur remained modest. Awards, honors, titles, none of it mattered to him as much as progress. He had little interest in personal glory. He cared only about the discoveries that would come next, about the diseases yet to be conquered. He still dreamed of a world free from suffering, where illness was no longer a death sentence, where science protected all people, not just the privileged few. In December of 1892, the French government organized a grand celebration for Pasteur's 70th birthday. It was a spectacle unlike anything he had ever imagined. Scientists, politicians, and world leaders gathered to honor him, to express their gratitude for all he had done. Tributes poured in from across the globe. France's highest officials praised him. Foreign dignitaries spoke of his contributions to all of humanity, not just his own nation. It was an overwhelming display of respect. Yet, as he sat listening, Pasteur remained quiet. When it was his turn to speak, he did not boast of his discoveries. He did not list his achievements. Instead, with a voice weak but steady, He turned to the young scientists in the audience and said simply, "These are the men who will complete my work." It was not about him. It had never been about him. It was always about the future. But the years continued to take their toll. His health deteriorated further. The man who had once spent hours in his laboratory, bent over a microscope, scribbling notes feverishly, now struggled to even stand without assistance. His wife, Marie, remained by his side, as she always had, supporting him in every way possible. She understood him better than anyone, knew that despite the frailty of his body, his mind had never surrendered. Even as his strength faded, Pasteur insisted on visiting the institute whenever he could. It was his second home, the place where his vision had taken form. The students and researchers there treated him with the highest reverence, hanging on to every word, eager to learn from the man whose work had shaped modern science. But time is relentless. In the summer of 1895, Pasteur suffered another stroke. This one was devastating. He lost much of his ability to speak. His right side, already weakened, was now almost completely paralyzed. He could no longer walk without help. His days of working, of teaching, of experimenting were over. For the first time in his life, Pasteur was forced to stop. His family moved him to a quiet estate in Villeneuve-l'Etang, hoping the peaceful countryside would offer him some comfort. He spent his final months surrounded by loved ones, resting in the gardens, watching the world continue without him. He would often sit in silence, gazing into the distance, lost in thought. Was he satisfied? Had he done enough? The world around him had changed beyond recognition. Hospitals were cleaner. Milk was safer. Vaccines were saving lives. His name had become a symbol of hope, of science, of the triumph of knowledge over ignorance. And yet, deep inside, Pasteur knew that his work was only the beginning. He had unlocked the door, but there were still so many mysteries left to solve. Diseases still ravaged the poor. Epidemics still took lives. He could only hope that the next generation, the scientists he had mentored, the students he had inspired, would continue the fight. On September 28, 1895, surrounded by his wife and children, Louis Pasteur took his last breath. The man who had saved millions was gone. France mourned. The world mourned. His funeral was attended by the most brilliant minds of the time, by leaders of nations, by people from all walks of life who had been touched by his discoveries. But even in death, Pasteur remained humble. He had no interest in statues or grand memorials. He had always believed that science was the only true legacy. And he was right. The Pasteur Institute continued. His students, his colleagues, his successors carried on his work. New vaccines followed. New cures. The fight against disease never ended. And his name lived on, not in marble, but in the millions of lives saved by his discoveries. Today, the world still remembers him. Every glass of pasteurized milk, every vaccine, every clean hospital ward is a testament to his relentless pursuit of truth. Louis Pasteur never sought fame. He never sought power. He sought only to understand, to protect, to save lives. And because of him, the world is a safer, healthier place. His work was done. But his legacy would never die.
Part 12. Aftermath and the Enduring Legacy. Louis Pasteur was gone, but his work was far from over. As the news of his passing spread, the world paused to reflect on the man who had reshaped science, medicine, and public health. Tributes poured in from every corner of the globe. Newspapers called him the savior of humanity, kings and presidents sent condolences, and doctors, farmers, and ordinary people alike mourned his loss. But even amid the grief, something extraordinary was happening. His discoveries were continuing to save lives. In the days following his death, the halls of the Pasteur Institute remained alive with activity. His students, his protégés, the scientists he had mentored, all carried on his mission. There was no time to slow down, no time to mourn for long. Disease did not stop. Microbes did not pause to grieve. There were still mysteries to solve, vaccines to develop, lives to protect. And Pasteur had taught them well. His institute, built upon his relentless pursuit of truth, became a fortress of science, a place where young researchers would continue battling the invisible enemies that had haunted humanity for centuries. Every day, new discoveries emerged from the laboratories, breakthroughs that would have made Pasteur proud. He had given them the tools. He had given them the knowledge. Now, it was their turn to fight. Outside the walls of his institute, Pasteur's influence rippled across the world. Hospitals began implementing sterile practices, embracing his germ theory in ways that had once seemed radical. Doctors washed their hands, cleaned their instruments, sterilized their environments, and the results were undeniable. Infection rates plummeted. Mortality dropped. More lives were saved, not through medicine alone, but through prevention, through the understanding that disease was not inevitable, that it could be stopped before it ever took hold. Pasteur had given the world more than just vaccines. He had given it knowledge, and knowledge was the greatest weapon of all. But his impact did not stop at the hospital doors. Pasteurization, the process that bore his name, spread across industries. Milk, once a dangerous source of disease, became safer, reducing infant mortality. The food industry, once plagued by contamination and spoilage, embraced his techniques, ensuring cleaner, healthier products for millions. His discoveries had reached beyond the laboratories and into the very fabric of everyday life. And yet, even as the world moved forward, Pasteur's legacy was not without resistance. Some skeptics still clung to outdated beliefs, unwilling to accept that something as small as a microbe could hold such power. There were those who doubted the necessity of vaccines, those who dismissed germ theory as exaggerated, those who preferred to believe in tradition rather than science. But history had already changed. The evidence was too strong, the successes too great. Pasteur's work had built an unstoppable momentum, and there was no turning back. Within a decade of his passing, new vaccines emerged from the Pasteur Institute. Diphtheria, tetanus, tuberculosis, all met their match as scientists, inspired by Pasteur's methods, pushed forward with tireless determination. Governments around the world took notice. Public health initiatives expanded. Mandatory vaccinations became law in many countries. Life expectancy rose. Epidemics that had once claimed thousands began to disappear. And then, in the early 20th century, another test of Pasteur's legacy arrived. The Spanish flu of 1918. A pandemic unlike any the modern world had seen, sweeping across continents, leaving devastation in its wake. But this time, the world was not unprepared. The principles Pasteur had established, sanitation, sterilization, microbial control, saved millions. Hospitals, now trained in germ theory, understood how to slow the spread. Researchers, following his methods, raced to study the virus. His work had given humanity the tools to fight back. But his influence extended beyond medicine. His approach to science, methodical, disciplined, fearless in the face of doubt, became the standard for researchers across disciplines. The fields of immunology, bacteriology, virology, all of them traced their roots to Pasteur's work. Every modern vaccine, every advancement in disease prevention, every medical breakthrough built upon the foundation he had laid. As the century progressed, Pasteur's name remained etched in history. Schools taught his discoveries. Laboratories bore his name. His institute expanded across the world, establishing research centers in distant nations, all carrying forward his mission. Even as new scientists emerged, new breakthroughs unfolded, his legacy remained woven into the very fabric of progress. By the time the 21st century arrived, Pasteur's influence was everywhere. The fight against Ebola, HIV, COVID-19, each battle waged using the very principles he had pioneered. Vaccines developed in record time, microbial research expanding in ways he could never have imagined. But at the core of it all, his methods, his discoveries, his unwavering belief that science should serve humanity. Even now, his name stands as a beacon. Hospitals, universities, research institutes, entire cities bear his name. Not as a monument to his ego, but as a reminder that knowledge is power, that disease is not invincible, that even the smallest discoveries can change the course of history. Louis Pasteur never sought wealth. He never sought fame. He sought answers. He sought truth. He sought to protect the world from suffering. And he succeeded. His work was done. But his legacy is forever.
Louis Pasteur had left the world, but the world had not left him behind. His discoveries had changed the very way science approached disease, and as the years passed, his ideas continued to evolve, expanding beyond what even he had imagined. The microscopic world he had unveiled, the one so many had doubted, was now the very foundation of medicine, immunology, and microbiology. Every scientist who stepped into a laboratory, every doctor who administered a vaccine, every researcher who fought to stop the next great epidemic was walking a path that Pasteur had carved. But the journey was far from over. As the 19th century faded into the 20th, the world of science grew more ambitious. Pasteur's germ theory had become an accepted reality, but its implications were still unfolding. Scientists had proven that microbes cause disease, but how exactly did they do it? What made some bacteria deadly while others were harmless? Could microbes evolve, change, and adapt in ways that made them harder to defeat? New names emerged in the field: Robert Koch, Paul Ehrlich, Alexander Fleming, each one building upon Pasteur's discoveries, each one pushing further into the unknown. Koch took Pasteur's germ theory and developed Koch's postulates, a set of principles that confirmed a direct link between a specific microbe and a disease. Ehrlich pioneered the concept of targeted drug treatments, searching for compounds that could kill bacteria without harming the human body. And then, in 1928, something happened that Pasteur himself might have dreamed of. A scientist named Alexander Fleming accidentally discovered that a mold called penicillium could kill bacteria. The age of antibiotics had begun. Pasteur had fought disease through prevention, through vaccines and hygiene, but now, for the first time, scientists had found a way to cure bacterial infections after they had already taken hold. Penicillin changed everything. Infections that had once been fatal, pneumonia, strep throat, syphilis, could now be treated with a simple injection. Hospitals saw death rates plummet. Surgery, once a gamble between life and deadly infection, became safer. The world was seeing another revolution, one that had started with Pasteur's microscope, with his insistence that bacteria were the true enemy. But as science advanced, so did the microbes themselves. By the mid-20th century, doctors noticed something troubling: bacteria were evolving. The very drugs that had once saved lives were now failing. Microbes that had been easily killed by antibiotics began developing resistance, learning to survive, mutating in ways that made them more dangerous than ever. The fight was far from over. It was a battle Pasteur had predicted long ago. He had seen how microbes adapted, how they survived in different environments, how diseases could spread in ways no one had imagined. His work on vaccination, his belief that the best defense was prevention rather than reaction, had never been more relevant. As antibiotics began to lose their power, scientists turned once again to vaccines, developing new immunizations against diseases that threatened to return. Polio, measles, mumps, influenza. Each vaccine was another weapon in the war Pasteur had started long ago, each one a testament to his life's work. But the world was changing faster than anyone had expected. With globalization, Diseases no longer stayed confined to one region. What once had been local outbreaks became global pandemics. Airplanes carried infected passengers across continents in hours. Cities swelled in size, bringing millions into close contact, creating the perfect conditions for new diseases to emerge. The very things that made the world modern, fast travel, urban expansion, industrialized farming, also made it vulnerable. Then came HIV. A virus unlike any before it. HIV did not just infect the body, it attacked the immune system itself. Traditional vaccines, the kind Pasteur had pioneered, did not work against it. The virus mutated too quickly, adapting in ways that made it nearly impossible to control. Scientists struggled for answers, knowing that if Pasteur had been alive, he would have been obsessed with stopping it. The world needed a new kind of solution. By the 21st century, Pasteur's legacy took another unexpected turn. Scientists studying the human immune system realized that the body had its own defense mechanisms, ways of remembering infections and fighting them more effectively the next time they appeared. This was the very principle of vaccination, but now researchers sought to harness it in a different way. Immunotherapy was born, a treatment that used the body's own defenses to fight disease, from cancer to HIV to autoimmune disorders. And then came CRISPR, a discovery that once again proved that Pasteur's work had only been the beginning. Scientists found that bacteria, Pasteur's microscopic enemies, had their own way of fighting off viruses. They stored pieces of viral DNA in their own genomes, allowing them to recognize and destroy future threats. This bacterial immune system was reverse-engineered into a revolutionary tool, gene editing. Now, scientists could edit DNA itself, correcting genetic diseases, developing new treatments for cancer, even engineering bacteria to fight infections. The war against disease had moved to a level of precision Pasteur could never have imagined, and yet, everything still traced back to his discoveries. His insistence that microbes cause disease, his belief in vaccines, his understanding that the microscopic world held both the greatest threats and the greatest solutions, all of it had paved the way for the future. Even as the world faced new pandemics, Ebola, Zika, COVID-19, Pasteur's work remained the foundation of modern science. Every outbreak, every effort to develop a vaccine, every new public health initiative had his fingerprints on it. His methods, his discoveries, his dedication to science had ensured that humanity would never again be helpless against disease. More than a century after his death, Pasteur's fight continued. The microbes still adapted. The diseases still evolved. But so did science. So did medicine. So did the understanding that knowledge is the only true weapon against the unknown. And in laboratories across the world, in hospitals, in research centers, in universities where young scientists peered into microscopes, searching for answers in the unseen world, Pasteur's spirit lived on. Part 14. The Future Shaped by Pasteur's Discoveries. More than a century had passed since Louis Pasteur peered into his microscope and saw a world invisible to the naked eye. A world filled with tiny organisms, some harmless, some deadly, but all capable of shaping the fate of humanity. His discoveries had revolutionized medicine, saved countless lives, and laid the foundation for microbiology, immunology, and public health. Yet, as science moved deeper into the 21st century, the world was still fighting the same battle. The war against disease had never truly ended. Pasteur had taught the world that knowledge was power, that understanding microbes, how they lived, how they spread, how they evolved, was the key to protecting humanity. His germ theory had shattered centuries of ignorance, yet new challenges continued to emerge, reminding the world that nature was always adapting, always changing. The same microbes that he had fought against now faced modern scientists in ways he could never have imagined. But his legacy had prepared them for the fight. One of the greatest threats in modern medicine was something Pasteur had glimpsed but never fully encountered: superbugs. Bacteria, once easily defeated by antibiotics, had begun developing resistance, evolving new ways to survive. In hospitals across the world, doctors saw cases where infections that had once been treatable no longer responded to drugs. Tuberculosis, pneumonia, staph infections, diseases that had once been on the decline were making a terrifying return. The weapons Pasteur had given the world were losing their power, and science needed new solutions. But even as bacteria fought to survive, so did scientists. Researchers turned back to Pasteur's principles: prevention over treatment, vaccines over reliance on medicine alone. Instead of waiting for infections to spread, scientists worked to stop them before they could begin. New vaccines were developed, targeting pneumonia, meningitis, antibiotic-resistant tuberculosis. The principles of immunization that had saved millions now became even more critical, proving that Pasteur's vision was more important than ever. Yet, bacteria were only part of the battle. Viruses, those strange, elusive entities that Pasteur had suspected but never fully understood, continued to wreak havoc. The influenza pandemic of 1918, the AIDS crisis, the Ebola outbreaks, and the COVID-19 pandemic reminded the world that infectious diseases could still bring nations to their knees. But this time, science was not helpless. The COVID-19 pandemic, like the plagues of Pasteur's time, spread rapidly, striking fear into every household. But unlike past pandemics, this time the world had Pasteur's discoveries. Scientists, standing on the shoulders of his work, developed vaccines in record time. They used techniques based on his principles of attenuation, his understanding of how the immune system learned to fight disease. Within months, millions of lives were being protected, not through chance, not through luck, but through the knowledge that Pasteur had uncovered over a century before. Yet even as one battle was won, another loomed. Climate change, urbanization, deforestation, all were creating new opportunities for infectious diseases to thrive. As human populations expanded, coming into contact with previously untouched ecosystems, new viruses emerged, some jumping from animals to humans, just as rabies and anthrax had long ago. Zika, Nipah, Hendra, SARS, each a warning that the microbial world was far from done with us. Scientists turned once more to Pasteur's legacy. Could vaccines be developed even faster? Could we predict the next pandemic before it happened? The world had learned that waiting until disease spread was a mistake. Prevention was the only real solution, and so, research efforts intensified. New technologies emerged: mRNA vaccines, AI-driven disease modeling, CRISPR gene editing, all carrying the same purpose that had driven Pasteur himself: to protect humanity from the unseen threats around it. But science was no longer just about fighting diseases, it was also about using microbes for good. Just as Pasteur had once discovered that microbes could be controlled to prevent food spoilage and produce vaccines, modern scientists were harnessing them in ways never before imagined. Bacteria were being engineered to fight cancer, viruses were being used to deliver gene therapy, microbes were cleaning up pollution, breaking down plastic waste, even generating electricity. The tiny organisms that had once been seen as enemies were now becoming powerful allies in ways Pasteur could never have foreseen. And yet, the greatest lesson Pasteur had given the world was not just about science. It was about the way science should be done. He had shown that skepticism must be met with evidence, that truth must be pursued relentlessly, that progress could only come from questioning what was already known. He had faced resistance, disbelief, and doubt at every turn, and yet, he had pressed on, knowing that the pursuit of knowledge mattered more than acceptance, more than recognition. That lesson remained critical in the modern world. In an age of misinformation, when vaccines, his greatest gift, were questioned, when distrust in science threatened public health, Pasteur's story stood as a reminder that knowledge must always triumph over ignorance. His journey had not been easy. He had fought to prove the truth, not for his own gain, but for the future of humanity. That fight, now more than ever, was still ongoing. As the 21st century unfolded, the world still carried his name. Hospitals, universities, research institutions, all bore the mark of the man who had dared to see the invisible and understand its power. His institute, founded to fight disease, now stood at the forefront of the modern world's battle against new and emerging threats. His methods had shaped entire fields of study. His discoveries had saved billions of lives. His vision had changed history itself. Even now, as scientists peered into microscopes, as vaccines were administered, as researchers worked to unlock the next great medical breakthrough, Pasteur's spirit lived on. His work was never truly finished. It was carried forward in every laboratory, in every hospital, in every scientist who dared to challenge the unknown, to push the boundaries of understanding, to believe that the smallest discoveries could change the fate of the world. Louis Pasteur had begun his journey in a small town in France, a boy fascinated by the natural world, unaware that he would one day save humanity from its greatest threats. He had worked tirelessly, sacrificed everything, endured hardship and doubt, all for the pursuit of truth. But his legacy, it would live forever.